6, use the graph shown to complete the following properties. In this case, you'll notice that we've done all of these properties before, but these phase shifts, we're going to ask you for what the phase shift would be if it was a shift of the regular sine function, a sine function reflected in the x-axis, a regular cosine, or a cosine reflected. There are an infinite number of equations that we can use to describe these sine functions. Why is there an infinite? Because these cycles go on forever. So what we're going to narrow it down to is a minimum translation horizontally, the closest one, rather than another cycle over or 10 cycles over. Because that, first of all, drives me nuts and your teacher's nuts to check on that. So you want the minimum. And then we're going to restrict it to a positive or a negative within both sine and cosine. So we'll narrow it down to 4. Okay, so let's draw your midline. So between -4 and +2. Oh, that's off. Sorry. Is that -1? That's better. Okay. Take a look here to the maximum. So the amplitude is 3. Okay. Take a look at, in order to get the period, what are each grid line worth here? So this is pi. It's split into normally 12, but just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or smaller, but it's rarely into tens, for example. So each grid marking is pi over 12. I'm just going to write that down to help us. Okay, so this looks like a maximum up here is 1 grid marking to the left, okay, of 0. And a maximum up here is 1 grid marking to the left of 0. So in that length there would be this, 1 grid marking to the left of pi. So if you think about it, that distance from here to here is pi units. Okay? So that means B is going to be 2. That B is 2. Vertical displacement from our midline is -1. Okay. Color. So we don't have our base graphs on there for you. It says, what's the minimum phase shift if the graph is that of a sine function? So let's pretend that we've done the stretch, the vertical stretch. Actually, we don't even need to for sine, but we've done that translation. So here, if there was no horizontal translation, it would be going up and to the right from the midline and the y-axis. Okay? Well, where's the closest that it's going up and to the right on our new graph? To the left. That's closer than over here. Right? So these are going up and to the right. So measure it or count your grid lines. 1, 2, 3, 4 grid lines to the left. 4 out of 12. Well, 4 out of 12 is pi 1/3. So it's pi over 3 to the left. So I'm going to put pi over 3 to the left, which is negative pi over 3. Okay. So count your grid markings. Now, if we do reflected sine, then from that midline, it would be going down and to the right. Okay, so down and to the right. Where is it going on next? Going down and to the right there. So what is that? That's 2 grid markings out of 12. 2 out of 12 is 1/6, so it's 1/6 pi to the right, so pi over 6. That's where your fractions come in, right? Oh, I put that I'm just going to erase this for the next part so that we can see it fresh. Okay, guys, can you focus? And then you can talk, right? And then you can help each other. But look up here to see what I'm doing. So if we're going cosine, its maximum, if it was stretched, it would be up here and going down, right? For a cosine function. So you do the vertical stretch, okay? And then translate it for vertically, right? So it would be going here and down. Our graph is over here, has a maximum. That's one grid marking to the left. One grid marking out of 12 in pi will be pi over 12, and it's to the left. So that's negative pi over 12 in terms of a phi phase shift. Reflected cosine would be going from the bottom up. Okay? So if we did that stretch, so y equals 3 cos, then reflected it, y equals negative 3 cos, it would be down here. So where's the closest up and to the right from a minimum is here. How many grid markings? 1, 2, 3, 4, 5. Looks like. Yep, 5 out of 12. So 5 pi over 12 to the right. Or positive 5 pi over 12. Okay, so what are our values of A, B, and C then? Absolute value of the amplitude is 3. B, we already calculated, is 2. D is negative 1. And then these are the C values that correspond to what we filled in here. So C, if we're doing a transformation on the regular sine graph, C is negative pi over 3. Pi over 3 left. For the reflected sine, it's to the right, so it's positive pi over 6. For cosine graph, it's to the left, so it's negative pi over 12. And reflected cosine is to the right, 5 pi over 12. So those are the only things that are going to change when we write out all of the equations. So we want the sine equations. There's 2 of them. Cosine equations, there's 2. Okay, the first sine was with a positive A. The second is a reflected, so negative. Same with cosine, positive and negative. So these are sine, these are cosine. Okay, B value is 2 for all of them. Then within that, there's translations, horizontal, so open bracket. And we're dealing with, is it theta or x? It's x in this case. So x minus negative pi over 3 will be plus pi over 3. X minus pi over 6. Then for cos, x minus negative pi over 12, so plus. And then minus. And then our D value is the same for all of them, minus 1. So the only thing that's different is whether it's a positive leading coefficient or negative, and the C value. if we put all of those into our calculator, should overlap, 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 overlap. They should all be the same graph. Okay. Says verify two of the equations with the point 5 pi over 12, negative 4. I'm just going to do it for one of them. So let's do it for the very first one. So to verify, I'm just going to put that into my left side and right side. So my left is y, which is negative 4. My right substitute that in. I'll do it in green here, I guess. See? Okay, so common denominator is 12, so that's 5 pi plus 4 pi is 9 pi over 12, which is 3 pi over 4. Which simplifies to 3 pi over 2. Three pi over 2 is down here where on my unit circle, the coordinates are 0, negative 1, so sine is negative 1. So it verifies. That's if you verify algebraically, right? Probably we're not going to ask you to spend the time doing that for more than one question on a test. But that's how you do it. Okay, take a look at the next one. Get a head start while we're waiting for people to catch up. Okay, so next one, same deal. Okay, so I look at my max is 5, my min is negative 1. So if I take the average of those, I get 2. And if I find the maximum, and count that up, that's 3. So my amplitude here is 3 as well. Okay, this one, again, doesn't quite show a complete cycle. So choose half a cycle, or even a quarter of a cycle, and then multiply by 4. But half is kind of nice from a min to a max. So this looks like a minimum. If I go along here, this is a maximum. Okay? Or you could go from here to here. That might be easier. Actually, let's do that, because more of it is, let's do that, more of it to the right. Okay, so from there to here. So take a look. This is 1, 2, 3, 4 grid lines to the left of 0. Okay, then we've got pi. Pi is divided into 12 parts. We've got 1, 2, 3, 4, 5, 6, 7, 8. So pi, 8 grid lines, 4 grid lines is another pi. So this is pi, that's half a cycle. That's a mountain. So double it, okay? Oh, sorry, what did I just say? That's pi plus another pi is 2 pi. So half a cycle is 2 pi. Double it is 4 pi. So the period here is 4 pi. Okay, so that means your B value will be a half. Vertical displacement, that's the red line. We'll look for that value. That's 2. Okay, so this is a different color. Phase shift, if we're dealing with the sine graph. So from that midline and the y-axis, we would be going up and to the right if we had no translation, horizontal translation. Okay, so the closest where it's in the same direction is here. That's 1, 2, 3, 4. Grid lines at a 12, which is pi over 3 to the left. Okay. For sine reflected from the midline and the y-axis, it would be going down and to the right. Where is it closest to going down and the right? Well, I can't even see over this way. And these are like basically the same amount on each side. So this one is actually closer. So how far is that? Well, that's pi. 8 grid lines, we already counted that out of 12. So it's pi plus 2/3 pi, right, which is 5 pi over 3. Okay, that's the closest. Okay. Just going to erase the, oh, I need to erase that one. Okay, so now for cosine, minimum phase shift for the cosine function. So if we've done the stretch vertically and the translation, it would be going at a maximum on the y-axis and going down without a horizontal translation. So that is easy to see what's closest because this one on the left is way over here. So we want to go over to this because it's going down and to the right. And so 1, 2, 3, 4, 5, 6, 7, 8. Grid lines out of 12 is 2 pi over 3 to the right. Reflected cos would be a minimum value of -1 on the y-axis and going up. Where is it closest to doing that same direction? It's over here. So that is left pi plus 1/3 pi. So that's 4 pi over 3 left. Okay, so now you can come up with your properties and your equations. If the period is 4 pi, 2 pi divided by 4 pi, guys, is a half. D is 2. C value, if it's left, it's negative. Right, it's positive. Left is negative. Oh, I got out of sync there just a second. 5 pi over 3 is to the right. 2 pi over 3 to the right. Negative 4 pi over 3. So all of these y equals, one's a positive, one's a negative. value is 1/2 for all of them. We're dealing with x's here. Oh, no, look at this. We made a mistake there. We call that the x-axis and it's theta. That's bad. So these are going to, we'll use theta. And then that's going to be to the left, so plus. And then d is going to be minus d minus d plus. Okay, I'm going to leave the verification for you to do. Okay? Gotta focus, you guys. Okay, girls. Okay, take a look at question 8. Okay, so turn over. We're not on a test going to ask you to write those 4 different ones, right? The majority is, once you get your A value, your B value, your D value, the thing that changes is your C based on those, we're going to say minimum phase shift, do a positive cosine. Or for another graph, minimum phase shift, do a negative sine graph. Something like that. So you'd only write down 1. So this says this still says determine 4 different ones. It says 2 of the equation must represent the sine function, represented in that form, and 2 cosine. So there's the note. 1 of the sine and 1 of the cos must also involve a reflection. So this one is all 4, but just be aware that we're not going to ask you all 4 on a test, because we want to give you a couple of questions as opposed to just 1 and get you to get 4 equations of it. Okay, so same. This is just the same, but it's not prompting you to find all the values. So maximum is 1, minimum is -1. So there's your midline. Take a look. If we go up to our max, amplitude is 2. What's a little more challenging on this is the scale for the grid markings. Okay, so there's your theta axis. It's split into 4 parts, not 12. If you take a look at where some of the values are, I can't quite tell for sure what that translation would be. Say, for example, if I was doing cosine. Okay, so we're going to have to think a little bit as we go through and actually do some math, which is good. First off, let's get some of these values though. So I know A, the absolute value of A will be 2. D will be -1. Okay. Let's do B next, because then everything will be the same throughout. So, first of all, let's get the period. Well, looking at that, I'm not quite sure about that point. Where does it repeat? There. That's a nice grid marking. Okay. If I go from max to max, that's not bad, right? It looks to be Well, the same, but again, it's not on a grid marking, so kind of hard. What I suggest you do is look for points either on the midline or maximums or minimums that are on grid lines and see how many cycles that is. For example, if I look at this minimum, it's on a grid marking. Each grid, remember, is divided, so that's pi over 4 there for one grid marking. Where does it end up on a nice grid marking again? Here, okay? So, what is this length? So that is 2 pi, right? Because that's one grid marking to the right, and this is one grid marking to the right. How many cycles do I have in that? 1, 2, 3. So that means one cycle would be what? What length? 2 pi over 3. Divide this length by 3 to get each of them. So the period is 2 pi over 3. 2 pi over 4. This. So the period is 2 pi over 3. Okay, so my B value, remember, is 2 pi divided by 2 pi over 3, which is 3. Okay, makes sense. We just said that. There's 3 cycles in 2 pi. We didn't even need to do this. So basically now, I'm going to set up my 4 functions. And this will get you part marks, right? You've done everything except the C value. So a positive sign and negative sign. A positive cos and negative cos. Now I'm going to go through and get the C values. Okay, so I'm just going to erase this so because it kind of gets in the way a little bit. So from my midline, okay, and my y-axis, my sine graph would be going up and to the right without a translation, okay? So where is the closest that it's going up and to the right? Here. This one is too, but it's further away. That's one grid marking to the left. Remember, each grid marking is pi over 4. So this will be plus pi over 4. Okay? Okay, so for negative sign, from the y-axis in the midline, it would be, it would be going down and to the right. Yeah. Just sit up. Okay, so guys at the back, listening please. So there's down and to the right. For the negative sign, I want to move here. It's not on a grid marking, right? You can probably estimate it. It kind of looks like a third of pi over 4. So I'm estimating that's pi over 12, but we want to make sure, right? Sometimes maybe it's not. So what can you do? Think about the properties of the sine graph. Each half of a valley or mountain is a quarter of a cycle, right? So from this nice grid marking, this point here is a quarter of a cycle to the left of it. So really you're taking pi over 4 and you're subtracting a quarter of the period. Okay, so if you think about that, find a common denominator of 12. That would be 3 pi over 12 minus 2 pi over 12, which is pi over 12, which is what we estimated as, but that would be some math you can do if you're not sure. Okay, so from a nice grid marking, I want to get to this point. I want to know what the theta value is there. So what's this distance here? It's a quarter of a cycle. That's how you can do the math. Basically, it looks like a third of pi over 4. It worked out to be the same. So my estimate was correct, and it was going to the right. So really important that you have good attention to detail, right? And knowing your fractions. Cosine from the max down is what it would be without a translation. Again, closest is here, but it's not on a grid marking. It looks like about a third of a grid marking. So it looks like it'll be pi over 12. Okay, let's use the same properties as before. This is a nice point at negative pi over 4. And this x value here is a quarter of a cycle. So now we're going negative pi over 4 plus a quarter of the period, which ends up being negative 3 pi over 12 plus 2 pi over 12, which is negative pi over 12. Exactly what we estimated it as, but that's how we can check it. And then the last one's pretty easy. From the y-axis and the minimum cos, so for a negative cos, it was going up and to the right. So next grid marking is pi over 4 to the right. So that one's pretty easy. So it depends on your graph paper that you're given, the information that you're given. You might have to do some math to figure it out, the C values. So this is more likely. What you're going to have to do on a test is come up with the equations, not graph them. The calculator can graph them. What could I do once I find, say I did all 4 of those? What would be one way of checking using my calculator if I did it correctly?
If you graph 2 of them.
You graph 2, what should happen? The same. So all 4 of them should be exactly the same. So if you graph them and say you got one was different, that's the one you've got to check your translation. Hopefully, if you entered all the other values, the size will be the same. It's just the location. Okay. Okay, one more to finish up. And I'm leaving the next note sheet is really practice, the exercises and the practice of basically doing the same thing, coming up with equations. This one's in degrees. 6 and negative 2. Average of that is 2. Amplitude is 4. Okay, so in this case, for a complete cycle, if you wanted to start here, you don't have a complete cycle, right? That's not on so here, if you start on the midline, that's half a cycle, you could double it. But notice if you start at the minimum over here, to this minimum, that's a complete cycle, right? So that will be your period. What is each grid unit here? So 180 divided by 4 is 45 degrees. So this is 2 grid units to the left, 2 to the right. So we've got 360 plus another 180. So the period is 540. This one is incorrect on the answer key, just so you know. So B is 360 divided by 540, which is 2/3.
See, now I hate working in degrees, because pi is just so much easier.
Well, divide out the pies and you've got it, so it is kind of easier. So let's write them out. That's it. So y equals 4 sine 2/3. This is in x plus 2. Y equals -4 sine 2/3 x plus 2. Y equals 4 cos 2/3 x 2.
If the minimum phase shift could be either way.
In either.
Should we put plus or minus?
No, choose one. Okay. You just don't want you choosing something like 4 cycles.
Like plus like 90 billion pi. It's like, thanks, I have to verify that now.
Exactly.
Okay, so from the midline, if we're doing just regular sine, it would be going from the y-axis and the midline up and to the right. So that's really easy, right? Just going to the right 45 degrees, so minus 45 degrees. Okay, sine negative would be this way. So there is another negative that you can see. Now, this is the question. So I'm just going to erase, just give me 1 second here. So we've only given you a snippet of this graph. Obviously, it's going down and to the right there. If I continue this graph here, which do you think would be closer? This one or that one?
This one, the right one. Going to the left.
The left one, exactly. Because take a look, that's where we're moving from. This, I have to move that 1 grid line and then half a cycle. Here, I'm moving less than half a cycle. So my minimum phase shift is over here. Okay? Well, what would that be? Half a cycle, remember, is here to here. So that is, what? Half of this is 270. Okay, so minus 45, I would be going to the left, so that would be a plus. 270 minus 45 is what? 225. Okay. So if it said minimum, if it said anything, sometimes we just say anything, but try to keep it minimum. In this case, probably we'd accept that anyway, just because of the graph that's given to you.
Would you accept the other one too, just because it's wonky?
over there.
Yeah.
Yeah, that's what I mean, like we probably would, yeah.
Yep. So we were going to.
Yeah, probably. Again, specifically, like, all the question was asking for minimum day shift, and we're really testing you on that, like just the C value, right? But if you're coming up with a whole equation, probably we would take them, because that's a lot of marks on that, to take it off for that. Cosine is up here and going down, so that's obvious that this is closer. That's 180 degrees to the right. And then cosine negative would be here up, and that is pretty obvious, so that would be 90 to the left. Oops, I forgot that.